Nope, gotta turn on my robot. Hi there. Hey, it's Wednesday afternoon, October 9th. I'm Rob, that developer dad, and we're continuing on with this NPC generator program. Just kind of filling in and fixing up the compiler warnings that Visual Studio has been nagging me about for quite some time. So let's just dive right in. On Monday, when we started this exercise, we had almost 50 compiler warnings. We are down to 4, and they are all living inside my test classes and test projects. So let's resolve those. Let's start here. Non-nullable field test class. Let's go ahead and make it nullable. Now that's going to generate some more compiler warnings. So we'll go here. And we'll just put a null coalescing operator here. What's it complaining about? NPC options? That's a nullable thing. What are you complaining about here? Doesn't match target type. So get NPC options. Wait a sec. I see the problem. So we're here, get NPC options returns a dictionary of string and string array. And my NPC options variable over here is string and nullable string array. So we got to come up here to the definition. And it is not, in fact, a null array there. And that's actually an important thing. A good rule of thumb when you're dealing with return types from functions and so on is if you're returning a single instance, null is okay. If you're returning a collection from your function or method or whatever it is, then you don't really want to return a null collection. You want to return an empty collection rather than the null. And I don't know why I made that made this a nullable value type. It doesn't make a whole lot of sense to me. But nevertheless, I did at some point, and because I just altered those tests, let's go ahead and run them. Make sure they still function for me. And I don't expect the dice tests to be impacted by this. These would be down in our townsfolk manager tests. And the get NPC options feature, it's got 3. And we're good. Okay, so we'll go back to our error list. And we're down to 3 warnings. So let's go find this deref of a possibly null reference. And background list is a nullable string array. So we'll do that. And we're good there. I must have just forgotten the null coalescing operator, or the null forgiving operator there, I should say. Got 1 more, 2 more. And assert.throws, invalid operation exception, test class get NPC options. Whoops, didn't want that there. That was a silly thing to do. We want to do that. There we go. And 1 more. Now we can use the null coalescing operator here, or the null forgiving. I can never remember what what the actual name of that thing is. It's either coalescing or forgiving, and I want to say it's forgiving. We can use this here because try get value on the dictionary type is not an async, and we're not awaiting it. Now, if I were awaiting an async method, then I would have to explicitly do the null check on the get NPC options instance here. But because this is an async, it's just calling a synchronous method, we can go ahead and use that shortcut here. And it looks like we've resolved all of our compiler warnings. I don't see any more. So I'm going to come in here, and the only thing that we've been manipulating is the test classes. So let's go ahead and run this. We'll run all of our tests. And there's that. Good. And let's do a clean. And what that basically does is it empties out the /obj and /bin files. Now, for some reason, it's complaining about a test assembly not found. Yeah. Whatever. We'll rebuild the solution, and that I'm sure that'll come back. I know we've got some NuGet package vulnerabilities. The compiler just warned us about those. That's what this is. So we'll go take a look at those in a second. Okay, well, we'll resolve these right now, in fact. So that developer dead, LLM access. So to make sure that we're using the same versions of the NuGet packages throughout, because that's something that we want to do. Let's go manage the NuGet packages for the solution. And if we've got a high severity vulnerability in system text JSON, I think we want to resolve that. So here's the vulnerable one. And let's see. The only one that seems to have it installed is this, which I find incredibly odd. Specific problems in your project. Try updating. Okay, yeah. This guy, we're going to bring you up to 805. Install. Here we go. We're in the installed. Let's do this. We'll do build and a rebuild. Make sure that doesn't come back. And then as soon as this is done, okay, so we still have 0 warnings. That's great. Let's come over to consolidate, because we've got a number of packages that have mixed versions. So Entity Framework Core SQL Server, I've got a couple of different versions of that. Let's fix that up. And let's find the ones that have those mixed versions. So we're going to come all the way to the top. We won't be referencing entity framework in our API or test consoles or engines or frameworks or managers. However, we are going to be referencing it in the resource access. I'm going to pull this a little further this way so that we can expand this. Any of the .SQL Server assemblies that we have are going to be referencing Entity Framework Core .SQL Server. So we want to consolidate these. And let's go ahead and just bring it up to the most recent right now. So we'll install those. Excuse me. And yes, we need to bring in all of these. I accept. All right, we're down to 4 dependency packages that are using different versions. So let's take a look at this one. These would be our test projects. Let's make sure those are consolidated. And we want to bring that up to, I guess we could go 17.11.1. Dice engine tests, Townsfolk manager tests, and that's it. Okay, let's consolidate, and we'll bring it to the latest stable. Install. Yep, I accept. And come on. What you doing? All right, let's do XUnit runner for Visual Studio. Yeah, we're going to want to consolidate those, all right. And it looks like, yeah, we'll go to the latest stable. Install. We'll do XUnit. Latest stable. Install. And this is usually relatively painless, like you see here. Sometimes it can get to be god-awful. So here's coverlet collector. Let's just bring it up to the latest stable for everything and install. All right. Updates. I guess we should probably do these updates. Azure Identity. That's just a patch, basically. Same thing with flow and assertions. Jot bearer. This WebAssembly.server. There we go. MS Graph. Identity Web. Semantic kernel. I'm really gun shy on updating that guy. And recandroll.xunit. You know what? I'm just going to select all except for semantic kernel. Because that one, updating this guy, always gives me the creeps. Let's go ahead and update. Yeah, that's fine. Do it. Do the thing. We should be down to 1 package that needs updated. And it's just semantic kernel. And I'm going to leave that alone. So, let's build clean. Clean is completed. We'll rebuild the solution. Rebuild all succeeded. 0 errors, 0 warnings. We've got some messages that talk about different things that we could do as far as style type stuff goes. I'm not sure I enjoy implementing those. Hello, Lisa Jordy. How are you? Hello, Father. That's funny. And let's run our test explorer. We'll run our automated tests. I'm quite all right. I'm just wrapping up some code maintenance, hygiene type stuff that I started earlier this week. Getting ready to launch this thing as an actual product. All right, so our tests all passed. I can close this and close this. Let's go ahead and run the application. I do not use Python. I've kicked its tires a few times. I like what I see, but honestly, I've been in the dotNet space for decades, and it's what I'm used to. And for the yes, C#, and for the use cases that I'm dealing with, I'll stick with what I know because that's what I'm most efficient in. If I were getting into some heavy duty scripting tasks, or say if I were needing to very quickly write a script to transform data from one format to another format, or if I were doing a lot of heavy duty scientific calculations or complex math like matrix transformations, I think Python's particularly good at. And also machine learning and AI work. Python is really well suited to those use cases. And C# is maybe a little weak in the machine learning use cases stuff. Yeah, AI assistants, so on and so forth. I've got a little bit of AI built into this. Let's say we're running our D&D game, and one of my players, oh, that's back-ass words. Ha! I found a bug in something that I cleaned up earlier this morning. So one of my players, they want to go to the blacksmith, and they decide to strike up a conversation with the blacksmith. And all I know is that there's a blacksmith, but we don't know what they look like or anything about them at all. So I can randomly, very quickly generate a blacksmith NPC. And then to get some additional information, I take those randomly rolled attributes and send those off to a language model. I don't have a perfect logo or overlay or anything like that. I've tried putting them together just on my own because I like doing things by myself, like on my own. I'm really into DIY type stuff, and it's just not something that I've prioritized into my time. You know, I'd love to set up an overlay and all of that stuff at some point, but honestly, it's low priority. I don't need things to look slick or anything like that. Yeah, I'll see what I can. I'll look into that in a little while. Um, So yeah, so here's Veladarath, our dragonborn blacksmith. We've fed the basic attributes that we essentially just rolled dice for. Hey, C Films, how's it going, man? And fed that into the AI, and we get out this description that I can use. And the whole process takes a matter of a few seconds. So let's say we need a shopkeeper or a tavern keeper. And we know that this one is a half elf. They are not retired. So it's gender ambiguous. Let's get some deets. I don't actually have Discord open at the moment, but I will definitely do so after the stream. But thank you for the offer. So let's see. And there we go. We've got Alden Thorn, 127-year-old half-elf, light brown complexion, long brown hair, often dressed in fine but practical clothing, suitable for a tavern keeper. Yeah. So we'll save Alden, and we'll go back to our list, and here we go. Now, we did observe that there is a bug in the create new NPC thing, and it's in setting up that initial state. I goofified that up. So let's fix that. We'll go to the UI, components, and it is on view NPC attributes. Yes. And show options panel, visibility. Yeah. Here we go. Toggle text, false. We actually want it to be, and this is a string. I don't know why I decided I wanted to do it that way. I want option, button text, show, save. Now let's make sure that as the visibility state of those options changes, let's make sure they stay correct, because I might have goofed that up. Easy enough to fix, though. New NPC. That still says hide. Show hide. That's goofy. I think it's backwards. Options button text show. So there is a selected species. I gotta come down here, I bet. Set option panel visibility. So should show. I do have those backwards. Now, Z. I'm just going to change. I'm going to swap these two around. Because when it's hidden, we want it to read show, and when it's shown, we want it to read hidden. And I had that backwards. Save all. Although I don't expect hot reload to actually work here. It's worth a shot. Go to new NPC, show, hide. There we go. That's better. I fixed it. And that's why just unit tests aren't enough. You got to take a look at what's actually rendering out on the screen. And error list. Here's this. Still no errors. Good. We've got a whole bunch of changes to commit. fixes the rest of the compiler warnings. Revealed throughout the solution. Commit. And let's push this up to Git. And off to GitHub we go. And I have, in fact, created some actions that run automatically whenever I push to a feature branch or initiate a pull request. And so we're building. Here's all this stuff. Yappa-dappa-doo. We're running our tests. And it's done. So let's go back a page. We'll go back one more. Boop. And once this is done, we'll be able to start to get a read on the history of some of these GitHub actions to see if, in fact, our total amount of time spent building and running our build and test has contracted. So prior, it's been between, let's say, 50 and 55 seconds. Refresh. 53 seconds. So no real serious improvement in our build time. Now, I would predict that if I had hundreds of compiler warnings and fixed them all, we would see a more marked effect of that exercise that we just went through. But our code is much cleaner now, and it gives a better impression. We don't see any compiler warnings. So if somebody else were to come in and start helping me with some of this code, they're going to go, oh, no compiler warnings. Gosh, okay. Let's try and keep this nice and tidy and clean. It's like when you buy a new car, for like the first few months, you don't like start just leaving your empty soda cans and chip bags and mail and stuff like that in it. But then, like, as time goes by, you kind of get less careful and less wanting to keep it looking and feeling nice and new and everything like that. The same kind of concept. If we keep the code neat, tidy, easy to read, all of that stuff, other people coming in to help us with our code are hopefully going to, by osmosis and by example, want to carry on that trend. So I think I'm going to go ahead and run the deployment. Well, no, before I run the deployment, I'm going to come out and do the pull request. So we'll go ahead and do this. Fixes the rest of the compiler warnings. I'm just going to create. Bam, off you go. It's going to run some checks. It's going to do the pull request. When do I decide to delete a piece of code? When it's no longer needed. That's the bottom line. If if I'm making a change to a piece of software, and in the process of making that change, I discover that I can eliminate a block of code because of the way I've made the change, I'll just do it right then and there. And if I regret that, I always do have my commit history and can always go back in time to a place before I deleted that piece of code and either copy and paste it back out, or do some source code control manipulation stuff and bring it back in that way. But I'm going to squash all of my changes into one big set of changes. We're going to delete the branch. There's probably a build happening right now. Yep, sure is. Or it's about to be built and tested again. But if we go to code, why do we have 3 branches? UX quality pass 3 weeks ago, update architecture docs. Okay, yeah. Those are all over on my MacBook. I may just delete these. I'm not sure. All right, check status 0 of 1. All right. And we'll take a look at our actions. And we're good. I'm going to go ahead and push this. Run the workflow. And that's going to do a build and push over from GitHub to Azure for me. It's largely an automatic process. We can see that it's doing its thing. So after build runs successfully, it'll kick over to deploy, and that should run just fine. So, back to talking about cognitive load. Let's look at, in our NPC service proxy, we've got these operations that are using the result pattern. And the result pattern is basically a way of wrapping the return of a function, or the return value of a function, in a result object. And that result object can carry the payload, which is what the function would normally return, as well as information about the execution of the function, including error messages or error log entries or whatever. And what it allows us to do is it allows us to always return a consistent type from our function, regardless of whether that function succeeded or catastrophically failed. It means we're not throwing exceptions up our call stack anymore, or back down the call stack, depending on how you visualize it. Because those exceptions, they can really mess with the internal runtimes, memory management, and so on. They take up a lot of space inside your process's memory and can have serious implications for performance. So by eliminating that big, giant, clunky, overly generalized exception object and all of its child classes, down to a simple, or not a simple, but a slightly more complex result object. Hey, thanks for the follow, and the raid. We've got heresy and hearsay. Raiding with a party of one. Party of one can be fun. So rather than sending back either the object that we're expecting or an exception, basically an error, a big complicated error message, we're returning an object that can contain a collection of error messages and or an instance of the type that we're expecting to get back from our function. And that really cleans up the internal execution space of the dotNet runtime. However, so this pattern is great for that purpose. The downside to this pattern is my save NPC method here has gone from being a simple pass-through where this is really the only line of code that really actually matters in here. It's gone from this line to also include analyzing the result and making sure the payload isn't null. And if the payload's null, we add an error to the proxy result and return early, and then we process the payload. And it's just, it gets really, really complicated for effectively a minor benefit. And we end up with this pattern scattered throughout all of our logic components, not just the service proxy, but we're seeing it in our API provider, or the workload provider. We're seeing it in our individual managers when they're calling out to remote resources. And it's really degraded the ability to easily look at what a method is doing and get a grasp on the work that's being done, because we've got all of this extra plumbing goo there. And I'm not in love with it. I like the effect. It's doing its job, but it's actually making it harder to reason about what the code is doing. So how do we solve this? And can we solve for this? We have a couple of options. Number one is we just revert to returning a task of whatever the expected payload is. In this case, it's the NPC client model. And go back to just chucking exceptions around our execution space. That's off the table. We're not going to do that. But there's got to be a way to extract these things away from the actual code that the method should be focused on. And there should be a way to do it in a way that doesn't create that doesn't just move this mess whole cloth to some other place in our code. And diving in and trying to hack together something also isn't a great option. So let's take a step back and do some thinking out loud. I may decide that whatever solution I can mentally come up with in the next 10, 15 minutes is actually messier than what I've got now. And if that's the case, then we're not going to worry about it. We're not going to do anything about it. Sometimes the right thing to do is to leave it alone. So when we, in a traditional scenario, let's add a box. And I want to change the fill on this to, this is nice light gray. And pull that down a scooch. Pull this down a scooch. And let's add some text here. Traditional dotNet function call. .NET function call with result pattern. Let's spell it right. And I'm going to need another text box. And we'll just pop this right in here. Go to the home thing. Pros. Add some dots. Simple. Easy to read. Yeah, that's about it. Cons. Throwing exceptions when errors occur means that the function may actually have more than one return type. The type we're expecting, and whichever exception types that could be thrown. Oh, come on. We also know that throwing exceptions around our call stacks can have consequences for the efficiency of our program. Now, there's two rules when it comes to performance optimization. And rule number one of performance optimization is don't optimize for performance until it's time to optimize for performance. And rule number 2 is it's almost never time to optimize for performance. Now, there are things that we can avoid doing that we know can absolutely torch the runtime performance of our applications. Most of them involve making serial HTTP calls across a very limited bandwidth network for, just misuse of the technology. But if we know that there's something that we can do just as part of the act of typing in our code that can prevent known performance issues without necessarily increasing the cost of writing that code, I think it's worth doing. Now, the result pattern is an okay way of handling that. It's pretty good. So I need to bring in another text box and put it up in here. We're going to do that. Boop. Pros. Cons. Pop up in here and add a bullet list. Come on. I said give me a bullet list. There we go. Eliminates the need to throw exceptions. We attach error information to the result classes errors collection. The generic form payload of type T gives us a lot of flexibility in the kinds of things we can pass back as the payload of a requested operation. Cons. This technique can add increase the complication level of the methods that use it, and frequently does. Another pro to this allows us to pass error information across network boundaries. Now, this statement that I've highlighted is true. It makes the code that uses it ugly and way more complicated than it needs to be. It increases the cognitive load required when dealing. It shifts the thought context. When used, it shifts the thought context away from the purpose of the function, purpose of the code that uses it, towards how does this work again. Higher cognitive load on the developers. That is not directly related to the solution space. And as an architect, I want to keep that as low as possible. As an architect, as a system designer, as a tech lead, what have you, I want to make sure that the people that are developing the solution can focus as much as possible on the actual problem we're trying to solve, instead of having to focus on how to use various patterns or this or that or the other thing. So while this OpResult of T, this generic OpResult concept that I've introduced throughout the solution, does a great job of eliminating the need to throw exceptions around when bad things happen, I'm gonna admit it right now, I'm failing miserably at that cognitive load problem. And that means I need to put more thought into what I'm doing here. And the actual mechanic around passing information from one component to another component, and then receiving the results of whatever operation that other component is performing at our request. And I've got some research to do. I'm not going to do it right now. There are some techniques that I've seen used and used in the past with older versions of dotNet, to see if I can come up with a sort of in-proc service proxy type thing that I can wrap around these calls to methods that are outside of the class that I'm currently working. So our call stack in this application, let's add a new slide. Not a new section, but a new slide. Here we go. So the way our call chains work is we've got a class, we've got our UI, it's a class. And then we go to another class, and then eventually we get to, some other thing. Resource. We'll have our UI, but it's a class. We've got our API, also a class. And we've got our logic. And it's usually classes. And it's most frequently, oh, come on. I don't want to fight with it too much. But most frequently, here's our shapes. Give me an elbow arrow. Here we go. We just go boop, to boop. And then we boop it one more time. Boop. And of course, then we pass back up the stack. What the heck? Let's add those. Let's get crazy. Just add a couple more elbow arrows. One more. So somebody does something in the UI, we cut UI, the application of the UI calls the API, which calls the logic classes, which call the resources. The resources return the information or the result of whatever activity to whatever class called it. Those classes return the information to the API, which assembles it, which assembles the results of all of those different things into whatever the UI is expecting. And when we don't use the result pattern, an exception down here can be thrown all the way back up the stack to here. And it might contain information about that resource, details about that resource, not to mention the performance issues and so on. But I don't want a user of my application, a user of my web application, to, surprise, surprise, I know the name of that database. Not only that, I know the IP address of the server. Even if that server is behind several firewalls and buried deep in a cloud environment or whatever, I want as little implementation information about everything from here on down to ever be visible to the end user. All I want the end user to see is, oops, something went wrong. Now, we want to log those details for sure, but we don't want to ever show the user or even have that information passed to the UI process. So what do? Is we don't throw those exceptions. We catch them, wrap them in an error object, and my error objects are dead simple. It's a GUID so that I can uniquely identify each instance of an error and correlate them. And it's just a simple text message that would get written out to a log or displayed on a screen or whatever. So we want to be able to pass those back as part of the response payload or the result payload. Or not necessarily the payload of the result, but as part of the result of the operation. But to do that, we've got to, whenever we call, like let's say our logic class calls a resource, and the resource does some work and runs into a problem, so it adds messages to the results error collection. When it comes and then returns it to the calling class. When that class receives it, it has to unwrap that result object and do a bunch of work to move the error messages into its own result object, because every method in our call chain returns one of these operation results of whatever the actual expected payload is supposed to be. And it gets really, really messy. Not only that, but when I go from a direct project reference to, say, a remote service, instead of just making a direct method call, as if I'm calling into just another C# method in another class, I got to go through an HTTP proxy or gRPC buffer or whatever. A message queue if I'm using those. And suddenly my logic classes are getting more and more weighed down with this mechanical stuff that's dealing with protocols and ports and type manipulations and all of this other stuff that I really don't want my logic developers having to deal with. So I'm thinking I want to look into establishing some sort of generic proxy pattern. And I'm going to have to do a little bit of research and a little bit of thinking and design, like code design on this stuff. But instead of iCharacter workloads being the dependency, we would, and I've named the parameter variable character proxy, and that kind of that's a little bit of a spoiler that I dropped in there early on in the process, that I do intend to introduce proxies for these things at some point, but I'm not quite sure how I want to construct those yet. And I need to do some thinking and experimentation. And I'm going to do that thinking and experimentation offline. It might not even be this week, but, well, no. I'm going to do that thinking and experimentation a little later on today. And if I come up with something that's going to work, then we'll start putting that in place tomorrow. We'll just hit it in vertical slices. I will go from UI to character workloads, and then from character workloads, we're just going to do one manager or subsystem proxy at a time, I think, rather than try to take on the whole thing in one big scary go. But I want to just do a quick proof of concept before I go ahead and do that. Or no, I want to have a design in place, and we'll do the proof of concept. We'll do the experiment together tomorrow morning if I'm able to come up with this generic service proxy concept. And it might actually allow us to get rid of this idea of operation results. And if that's the case, that'll make me very, very happy. Very happy indeed. Because this is a big messy mess. It's way too much code to basically request some data from a database via an actual manager or via an API that calls a manager that calls a data access component or resource access component. All of that post-processing just feels clumsy and is ugly. So if I can find a way to wrap that up or make it consolidate it into something a little easier to deal with that hides all that complicated code, that'll make me very, very happy. So this is a good session. We completely got rid of those warnings. Oh, look, there's two back. I probably made a change to something. There's a known. Oh, yeah. Right, I flipped to main. Silly me. Let's sync. Excuse me. There we go. We're back to zero warnings. And tomorrow we're going to create a new branch just as an experiment. And we're going to see if we can start simplifying this, this stuff. So cool. Thanks for joining me. Thanks for hanging out. Lisa Jordy, I'll zip you that Discord message in a few minutes. And we'll see about some of these templates. So thanks for joining me. Take care of yourselves, be kind to the people around you, and happy coding. We'll see you tomorrow.